Looking for a fast-charging, ultra-responsive stylus for your iPad? Meet the 2X Fast Charge Active Stylus Pen, designed for 2018 to 2025 Apple iPads. Take your creativity and productivity to the next level. Click the link in the video description to shop now on Amazon.
Welcome to the Google Trends Hub channel. Today we're talking about a fascinating story that's been making waves in the world of artificial intelligence. You might have heard about Google's Gemini 2.5 model, which recently achieved something amazing, beating Pokémon Blue across over 106,000 in-game actions. But before you start thinking that this is some kind of benchmark for large language models, let's take a closer look at what really happened. It turns out that Gemini didn't quite succeed on its own. It needed some significant outside help to make progress in the game. According to developer Joel Z, Gemini's success was largely due to an external agent harness that provided the model with critical information about the game's state, navigation challenges, and even generated a textual representation of the minimap. Now, this might sound like cheating, but remember what Joel Z said. Humans naturally build mental maps while playing games, something current LLMs can't do independently yet. The minimap feature compensates for that limitation. Essentially, Gemini's harness was giving it the tools it needed to succeed where other LLMs were falling short. But here's the thing. If we're going to use this as a benchmark for AI models, we need to consider the level of intervention required to help them succeed. And in Gemini's case, that intervention came in the form of specialized agents tailored for specific tasks, like generating potential solutions for the boulder puzzle on Victory Road. So what does this tell us about the limitations of LLMs? Well, as Les Wrong's Julian Bradshaw puts it, without a refined agent harness, all models have a hard time simply making it through the very first screen of the game, Red's bedroom. That's right, even with the latest and greatest reinforcement learning tools, we're still a long way from creating an AI that can figure out a way to beat Pokémon just because you asked it to. But here's the thing, this isn't about beating Pokémon, it's about what it means for us as humans. Are we truly on the cusp of creating something that surpasses our own intelligence and capabilities? Or are we just patching together workarounds with external help? These are the questions that AI researchers like Joel Z and Julian Bradshaw are grappling with, and they're worth exploring further. After all, at Google Trends Hub, we're always curious about what's next and what that means for us as humans. Thanks for joining me on this story. Let me know in the comments what you think. Can we really create an AI that beats Pokémon?